Alright.
Bigger than the jokes are scripted.
You'll never know. And you're thinking, was that scripted? We're going to talk about the chain rule today. Chain rule, oh man, it's so cool. It lets you tie all this calculus stuff together. This is the last major rule that we have. We will talk about implicit differentiation, which leads us to related rates, something very useful for you. But as far as the rules go, this is it. This is the last derivative rule that you get. Other than that, it's pretty much just applications. So that's kind of nice, right? So basically the rules are product rule, quotient rule, chain rule. Most of your calculus rests on that. Most of your derivative rests on those rules. So what this is, what the chain rule does, it gives you a way to do derivatives with compositions. So it lets you take derivatives by using compositions. And just to refresh your memory on why we might do this, I'll give you that example again. It's on the last video, so I want to make sure it's on this one as well. This is the reason why we want to learn the chain rule. I gave you this to you earlier. I said, can you take the derivative of that thing? Easily. In fact, if I did this, derivative would be 6x, and then you're done, right? And I built on it a little bit. I said, okay, well, what if it's not that? What if it is squared? Could you still take the derivative? Yeah. And so yeah, you probably FOIL that out, right? Distribute it, and then take it term by term. I said, okay, well, what happens if it's cubed? And you go like so the same thing, or use the product rule. I could still do that. Distribute one of them, use the product rule. But as soon as we get to things like this, and I think this is where I went the oh crap, right? You go, come on, man, are you serious? Do we really have to do that? Yeah. But if you think you're going to distribute this 100 times, I mean, that's just a waste of time. So there's got to be a better way to do derivatives of this. And as a matter of fact, there is, and it's actually not hard. It's kind of an easy way to do it, and you're going to like this. So all the times where you've had to distribute, remember like when you had this squared, you had to distribute that, right? Like in the first set of homework, you're like, oh man, this is tedious. We'll end the tedium. Now this takes care of that. So anytime you can see a composition, I'm going to show you the composition here in a second, you can use the chain rule. So I come with theme music now. All right. The question is, can I express this thing as a composition? Which is why I had you cover compositions and had you go with the reverse of compositions, looking for a function within a function. That's why we did that. So we get to this point like, oh yeah, I kind of understand that idea now. So can I express this as a composition? And the answer is, yeah, I can. And here's how you do it. Here's a pretty basic way to do these things. What you're going to do, you're going to cover up the inside of your function. So what I mean by the inside here is the 3x squared minus 4. You with me on that? You're going to cover that up, and you're going to go, okay, I'm going to make a function y equal to whatever you covered up becomes an x. You know what? Let's make it a u. A u to the 100th. Make it a u to the 100th. Do you see how I got that? Do you see that by holding this part out, I get a function that's very basic. Y equals u to the 100th. Do you see where the u to the 100th is coming from? But then you have another function to express. You now need to say, okay, well, u is going to be, what did you cover up?
3x.
Then that has to be your u. And that would be a very basic composition. Do you see if I put the u in for this u, this expression in for this u, I'm going to get that back again? Can you see the composition here? basically, if you cover it up, you go, okay, that's u to the 100, and u is what's under my hand. And that's how we get those two things. Raise your hand if you feel okay with that so far. So sure, this is a composition. That's not bad at all. Well, could you find dy du? Could you find that? What's this mean to do? Derivative of y with respect to what? Oh, with u. Okay, so do it. What's the derivative with respect to u? That should be a very easy one for us.
100 to the 99.
You okay with that so far? You sure? Okay. Could you find du dx? Could you find du dx? That's the derivative of u with respect to x. How much is that going to be? That's the 6x. Are you okay with these two things so far? So we write this as a composition. We take the derivative of the first expression, that's the overlying function. We take the derivative of the inside expression, that's what we chose as our composition to compose into that. But the problem is this. What we ultimately want to find is dy dx, right? We don't have that yet. We have dy du, we have du dx, but you're going to find out right now why we stick with this notation, because this is kind of cool. Are you ready for it? If we want to get dy dx, so what about dy dx? What about dy dx? The question is, can we put these two things together in such a way that it will equal dy dx? For instance, I'm looking at a dy du, and I'm looking at a du dx. Do you notice how the du here is on the denominator, and the du here is on the numerator, and we have a dy on the numerator, which we want, and a dx on the denominator, which we want? What operation can I put between this one and this one so the du's will be gone and I get dy dx? Yeah, you know what? Look at this. If I say, well, let's just take dy du, let's multiply it. That looks like an 8, didn't it? Let's multiply it by du dx. The beauty of this notation is that those little pieces do act like something you can cross out, something you can simplify. So what happens to the du's in this case? They're gone. This right here is the chain rule. What it says is that dy dx will be equal to dy du times du dx. This is chain rule. That's the chain rule. Okay, so how do we use it in practice? Let's apply it to this scenario, okay? So when I ask you for d dx of 3x squared minus 4 to the 100th power, who cares where you got that from? Can you do the derivative? Here's what it says. It says take your dy du,
Look, you want to mess with this. How do I... Can I rotate this? Oh, wait, it's actually kind of crazy. What the hell? Rotate it. Oh, shit. Yeah. Yeah. Yeah, I'm going crazy, bro. Fuck.
take your dy du, that's this. Okay, I'll show it to you that way. Take your dy du times your du.
Don't let you do that.
That's the chain rule.
Okay.
Okay, so how do we use it in practice? Let's apply it to this scenario, okay? So when I ask you for d dx of 3x squared minus 4 to the 100th power, who cares where you got that from? Can you do the derivative? Here's what it says.
Alright.
It says take your dy du take your dy du, that's this. Okay, I'll show it to you that way. Take your dy du times your du dx. In our case, that's the derivative with respect to u of u to the 100th. That's where we got this, right? Derivative with respect to u of u to the 100th. Are you seeing where that's coming from? Then it says time.
Let me see, hold up.
Okay, so how?
dx, d over dx for 3x, 3x.
To the 100th power. Who cares where you got that from? Can you do the derivative? Here's what it says. It says take your dy du take your dy du, that's this. Okay, I'll show it to you that way. Take your dy du times your du dx. In our case, that's the derivative with respect to u of u to the 100th. That's where we got this, right? Derivative. With respect to u.
Hold up. Just see what. Yeah. Alright. Let me think. Oh crap, what did I just do? It's just going up a week.
Jesus. You can solve. You have U100. Are you seeing where that's coming?
Dude, I've not fucked with my summer classes, bro. It's some ass. So yeah, I'm fucking thugging out this bullshit. I'm gonna play some games after, but I'm fucking thinking there's nothing better to do this than just stream it.
From? Then it says
I'm just gonna holy shit.
times the derivative of the inside, the 3x squared minus 4. That's the du dx. Do you see that dy du is this thing? It's the derivative of your function with respect to u. That's what this part is. Are you okay with that? The du dx, that's the derivative of what you call u. The derivative of what you call u is the inside part. If we take that
I'm already
derivative,
lost, bro.
it says multiply dy du. That's right. Derivative with respect to u of u100. Are you seeing where that's coming from? Then it says times the derivative of the inside, the 3x squared minus 4. That's the du dx. Do you see that dy du is this thing? It's the derivative of your function with respect to u. That's what this part is. Are you okay with that? The du dx, that's the derivative of what you call u. The derivative of what you call u is the inside part. If we take that derivative, it says multiply dy du times du dx. So take the derivative of the overlying function, multiplied by the derivative of the inside function. That's what this says to do. What was this again? Times, what was that again? Do you see a problem with this? Yeah, we have x's and we have u's. We want which one? We want x's. Do you know how much u is equal to? Sure, that's why you had this over here. So if we can do that substitution, we go, okay, the x looks great to me, but the u doesn't look so great. I want to make that u back into what u equals. So let's do that. We'll get 100, 3x squared minus 4, because that's our u, to what power? Don't forget about the 99th power. Don't forget about the exponent. Times 6x. Now, you could make it a little bit prettier, but I want to come back to this and talk about this for a second, okay? Because I want you to see the practicality of the chain rule. Firstly, what are you going to do with this?
What the hell?
You're going to do something with this. What are you going to do with the 6x? Multiply by what number? Yeah, do that. Okay, don't leave it hanging out there as a times 6x at the end. Now, naturally, please don't do this. Don't distribute the 100. Okay, you can't do that because that's an exponent. That says in order to distribute the 100, you'd have to FOIL that out 99 times. Do you get it? Please, for heaven's sakes, don't do that. All right, don't do that. Just multiply this number times this number. And we get 600x. X squared minus 4 all to the 99th power. That's it. That's a pretty easy way to do a derivative, isn't it? Not too bad. Now let's look at what actually happens here, because I want you to see this. This is going to be in general what we did. Is there a way that you can get from here to at least, well, actually probably this step, but we can get almost from here to here in one step without showing a u, without showing a du dx and a dy du, without showing that stuff. I want you to think about what we're doing. Do you see what happens to the 100? What happens to the 100? Yeah, that's basically just your power rule. Do you see it? The 100 comes down to the front. You leave this thing alone, right? That's in the parentheses. It says you leave it alone. Why do you leave it alone? Because you end up substituting back in the u. That's why, because with the composition, you're going to get that u back again. Do you see that? You're going to have some u here. You're going to get that. So we have a u back again. That means you don't change it inside. Where's this piece come from? Where's the 6x come from? Yeah. And this is called the general power rule. It's a corollary of the chain rule. The chain rule is the overarching idea, but what we can do oftentimes with this is something called the general power rule. And it says the power rule works in general if you do this. And I'm going to show it to you right now. So general power rule, product rule, okay, you get the general power rule from the chain rule. Do you understand? So the general power rule says what if you need to take a derivative of some function to some power? What if you need to take the derivative of some function to some power? Here's how you do it. This is called the chain rule. And here's how you do the chain rule. I can show it to you if you really want me to. This is what would happen. You'd say, okay, what's my function? You'd say y equals u to the n. True? Where u would equal f of x. Do you believe me? You follow still? That's what the chain rule would say. Well, this says, okay, if I took the derivative of u to the n, remember your power rule? Power rule says you bring down the exponent, you subtract 1 from it, true? This would say, okay, dy du would equal n u to the n minus 1. Follow me so far?
Hold on. Oh, yeah, I got it.
Du dx would be the derivative of f of x. That's, oh, how do I want to write it? I'll just say this. The derivative of f of x. You could write f prime of x. You could write that as well. Are you guys okay that the derivative of u to the n is n u to the n minus 1, and the derivative of f of x is the derivative of f of x? Does that make sense to you? I'm writing this way so we have a formula in just a second. Do you see the chain rule at work? We have dy du, we have du dx. So in order to find dy dx, we'll have dy du times du dx. Well, what that says is do a substitution. That's n u to the n minus 1 times the derivative of your function from the inside.
Jesus. dy over d. And
how much is u? What's u equal to? Because we did that composition. What was u in our case? So do that substitution back into there. And what you end up getting is n f of x to the n minus 1
times f prime of x.
d dx of f of x. Now, did we say anything about f of x at all? Did we make any qualifications about f of x? So then this should work in general, right? Anytime we have a function raised to some power, we could use the chain rule on it every single time. We led to a formula. I just invented this formula for you. Did you guys see it? It's kind of cool, right? Invented the formula for you. We did a composition. We can do that. We took the derivative here. We took the derivative here. We know that to get dy dx, we multiply those two things. Then we just do our substitution back in for u.
Yeah,
what that
what the
says is,
fuck?
if you want to take the derivative of some expression raised to some power, all you've got to do is take the derivative of the expression times the derivative of the inside. That's what you're doing. Bring down the exponent as usual, then multiply by the derivative of the inside. That's what this says in English. Look at what it says. Bring down the exponent as usual. Bring down the exponent as usual. Then multiply by the derivative of the inside. Inside. That's what that says to do. Raise your hand if you feel okay with that. So do you have to show me all this to do it? No, I just proved it for you. This is kind of a proof for you to be able to do that. You get it? So in English, if you want to hear this in English, bring down the exponent as usual, as you normally do for the power rule. That's why it's called the general power rule. So bring down the exponent like it's a power rule. Just multiply by the derivative of the inside. You just can't forget about the derivative of the inside, because this thing matters for sure. If you don't have the 6x here, does it affect your problem?
Yes.
Oh, heck yeah. Yeah, by a long shot. Okay, so that does matter. Bring down exponent and multiply by derivative of the inside. Would you like a couple examples to kind of work through this? And then after that, I'll show you some more applications of the chain rule, stuff that we can do with some trigonometry, which I know you're going to love, right? Stuff you can do with that, and that you can't forget that you need to do with that. I'll show you how to work with the chain rule. And then after that, we'll talk about implicit differentiation if there's a little bit of time. Okay, so let's discuss this problem. If I want you to find dy dx, which is what I want you to find, could I just do this? Could I just take the derivative of this and this and this and leave it to the fourth power? The answer is no, because this is a composition. You guys see the composition. This you could cover the whole thing up and call it u, or sorry, call it u to the fourth. Y would equal u to the fourth, and u would equal this stuff. Does that make sense to you? We could do the chain rule here. Does this fall into the category of general power rule? Is it some function raised to an exponent? That's what we're looking for. Do you guys see the power rule in it? How we get the power rule? That says, here's what we're going to do. We're going to do the power rule just like we normally would. We'll bring down the exponent, we'll subtract 1 from it. Just don't forget to multiply by the derivative of the inside. So you tell me what to do now that we've talked about it. What do I do?
Bring down 4.
Good, 4 goes down. Do I still have an expression here?
Yes.
What's going to be on the inside of my expression? Do I change this at all from here to here? No, that's because that kind of original function. Is that okay? Are we done now?
No.
We're good though. We bring down the exponent, we subtract 1 from it, and now you get to do this part. Note all about where the dd are. Why am I going to mark points off from you?
Yes.
Absolutely. Why? I need to have the parentheses firstly. That says I'm multiplying the whole entire expression. Now, you got a couple choices. You can move this thing out front, and you can distribute that 4 into there if you'd like. Just make sure you have parentheses around it if you do it. Does that make sense? So that you might see,
Distribute the 4.
or you might see the problem end like this. Just make sure you have parentheses there, or otherwise, yeah, I'm going to mark you off because that's a different statement. Now, your question is, which one do you want, Mr. Leonard? And I go, as long as you need to hear, I'm happy with your calculus. Now, I want one of these two. I want one of those two out of you. What I can't have you do, don't keep going. Okay, there's no way you should ever foil this into the, actually it'd be foil oil, right? Outside, inside, but you should never do that because that's to the third power. You can't break the order of operations. Exponents come before distribution or multiplication does, okay? So you can't break this rule. But this would be perfectly appropriate. How many people feel okay with this so far?
This is the answer.
Are you ready to see that we've been doing this literally the entire time with our power rule? See, the general means encompasses all, right? So check this out. If I give you x to the sixth, just a simple example, and I say, why don't you take the derivative of x to the sixth? You know inherently that that is 6x to the fifth, right? Okay, inherently. Actually, it wasn't inherent, I guess, because I taught it to you. But you know it nonetheless. But if you applied the general power rule of this, check it out. If you said, oh, well, that's a function in terms of x, I'll write that a little better so you can really see it. If I said that's a function in terms of x, could you do the general power rule to it? And the answer is, yeah, you could. Check it out. You would do the 6. X to the fifth, remember that would be in parentheses, right? Because that's your function. Times the derivative of whatever's inside, only this time the inside is x. What's the derivative of x? That's why we didn't have to show that, because the derivative of the inside is always the same thing. It's always just x. Do you get it? We've been doing the general power rule, we've been doing the chain rule the whole time. It was simpler, because we didn't have that inside. So that would become 1, and you get 6x to the fifth. Interesting. We've been doing it. That's why it's called the general power rule, and we had the power rule before. You ready to keep going?
Yes.
Okay. Let's try a few more. We're gonna. Distribution is one of them. Give me another way. Now you have 2 ways to do this problem, right? As soon as I do this, do you still want to distribute? No. In fact, if they gave that to you before, that would be how you had to do that, right? Because there was no way to get rid of that 3 for you without foiling that all out and then distributing. Or foiling at least this out and then using product rule. In fact, maybe you had to do that on a couple of your examples, and it's like, darn exponents. But now let's look at this for what it is. This is a derivative. Can you see a product rule in it still? Can you see a general power rule in it right now?
Yes.
Question is, which one comes first?
General power rule.
Well, half of you are right.
Which half is the question?
That's the question. Which one, working from the outside in, which one encompasses more of the problem? You should be able to say this. You should be able to say this whole thing has to do with, does the whole thing have to do with the general power rule? Which means, is that exponent of 3 applied to the whole thing right now? General this is also rule.
What? Wait. Why did you bring that?
Does that make sense to you? It'd be the same as this question.
Fuck.
Which one would come first, a general power rule or a quotient rule? What do you think? Definitely the general power rule is only applied to this little top part, right? It doesn't encompass the whole problem. The quotient rule encompasses the whole problem. That would come first. Work from the outside inside. Now, if I did this, you'd hate me, first off. Which would come first in this case?
Chain rule.
Chain rule. In our specific case, this would be, you can say chain rule, that's fine. This would also be called the general power rule. Do you see it? General power rule, and then you would do the quotient rule.
Then general power rule.
And then general power rule inside of that. Yeah. Okay, that would be nasty. One way that you could make this easier if you're looking at it, you could take both this exponent and say, okay, this is now to the 10th, and that's to the 5th. That might make it actually a little bit easier. But starting out, you would see the general, I'm just making a point here, you'd see the general power rule first. Do you see what I'm talking about? You see the product rule first here. It encompasses the whole problem. And that's how you diagnose these things. What do you do first? Whatever's encompassing the whole problem. And then you work your way inside and you follow the DDX, and the DDX will tell you what to do. Are you ready to do this problem? Let's do it. So first thing we see, okay, connecting this thing is a multiplication. That means a product rule. Set up the product rule. Go for it.
Get the hell out of here! Cool. F prime x times g of x plus f of x. Start off with plus this is just 2. Three goes in front. Square root is 5. It's 2 times 2x times 2x 3. Bro, got the I've used that, dude. This fucking calculus shit sucks. I hate it, bro. 2x squared minus 10 times. Thanks, DK. I'm probably gonna get off. I'll probably play a game like in an hour or two, though, regardless, though. Because I freaking hop in VC.
Yeah.
Hello?
We make a good team.
What's up?
It's like, it's not bad. It's like, it's more of like, what's it called? It's just like, like not even tedious. It's just, I have that, because I'm freaking compressing all of it in like 8 weeks or 7 weeks.
But you've already learned calc.
Yeah, I know, and I'm like remembering all of it, but it's still like bits and pieces that are like a little stuff that I'm forgetting. It's annoying. But yeah, I remembered a lot more than I thought I did, which was like surprising.
Yeah.
Because I freaking like slept in that class half the time.
I forgot you. Yeah, I forgot you had that class.
That was senior year with some buns. At the end of the day, oh my god, that was sucked, bro.
At the end of the day, what?
I had calc. I was literally
Oh,
just waiting.
yeah, I remember walking into the class and this motherfucker just gooned out.
Just waiting for the day to end so I could go to track, bro. 'Cause I hated that class. I'm surprised, like, I really, if I applied myself, I probably could have done well, because, like, this shit ain't that bad. But, we'll see. I think that this...
How's your video coming along, bro?
I edited, like, a good amount into it. But, like, right now, I'm, like, doing, like, a lot of, like... Like, there's, like, highly edited areas that's taking, like, longer than if, like, I'm not getting, like, a minute, like, my
I'm
usual
down,
ratio.
but what time are you going?
Yeah.
Because
But up tonight,
if I
I'm
go
gonna
with
edit
you,
a
we're
little
gonna
bit
be
more, and I
out till
think
5,
I'll
right?
be able to, what's it called? Get a lot more done.
Wait, Nick, say penis.
Penis?
1, 2,
So if
3,
we can
4,
wait,
5,
no. I feel like it's better if I just finish this.
7. It's like
But I don't
7
wanna make you
second
wait too
delay.
long.
7-second delay, yeah.
I feel like by the
Yeah.
time can you pick me up or are you going to one near you so I can drive up?
Alright, I'm a deafen, and I'll probably undeafen when I hop off.
Which one are you going to?
Hop off calc, bro.
About
Like,
to
which
go to the what's it called? Go to the mall. Gotta get my sister some. I'll just be
Yeah.
AFK.
How
for a
far
few
is that?
hours.
Alright. See. The square. Wait, what am I doing wrong? Two x plus the 3x squared. Oh, then times 2x that's 4x squared minus 6x. Jesus Christ. 4 60 squared fuck 12x4 minus 18x cubed minus 60x squared and then plus, holy shit, 15, 30, 90, 90x plus 2x squared minus 10 to the third.
This one? I want you to first. How many people feel alright with this so far?
Let's see what I have. Oh shit, I already messed up. Wait, no.
I'll try to be more straight on the next one. We just take this. No, it's basically a problem within a problem. What's the derivative of x squared minus 5 to the third? What rule do you need for that? Chain rule, or the corollary to that, because it's a specific version of the chain rule, is called the what? General power rule. So this was a product rule, and inside of that had a general power rule. General power rule says, well, what I'm going to do, don't change, and the chain rule, that is the...
Alright, I got that.
Yeah, so we have ddx down, that tells you where to take the derivative of, or what to take the derivative of. So we're basically all done up until that point. We have 2.
Crap.
X squared minus 5 to the third. Let's not mess up any exponents.
Yeah, that thing, single thing messed me up, bro. I need to wait. Never mind.
Fuck. 2x minus 3. Bigger. No, that's 15. Combine some of those like terms. Now, if we can make people feel. After that, it's just algebra, some manipulation.
Okay. What did I get wrong? Plus 2 2 Oh no, this is 6x though. Times 2x. Why did he? Alright. 2x squared minus 10 to the third plus 18. Oh no, that's 12. 12x minus 18x. 2x times x squared minus 5 squared. Oh shit. Dude, those cancel out.
A lot of times that happens when you do the product rule and you have a general power rule. You're going to want to factor that at the end. It makes things a lot nicer. So I'll show you what I'm talking about. If we go ahead, maybe make this just a little bit prettier, we have this. This becomes 6x. Like that. Are you okay with that so far?
Make this 6x.
Yes, no? Do you see the factorization of what I'm talking about? Yeah. We have this big factor and this big factor right there. We can pull out, what can we pull out of that? If I pull out the x squared minus 5 squared, what I end with is 2 still there, x squared minus 5 to what power? Good, because I pulled out 2 of those things. Does that make sense to you? Plus 6x, 2x minus 3. Are there any of these left? No. I've factored that out. Notice you could get the same thing if you distributed. This distributes and give you this distributes and give you that. Okay, so that's factorization right there. Raise your hand if you feel all right with that so far. The next thing you do, distribute this in combined like terms. If you distribute this in combined like terms, you'll have a much simpler looking polynomial. So in here we get our 2x squared minus 10. We get our 12x squared minus 18x. If I did it right? Did I do it right? Yeah. If we combine some of those like terms, I'm seeing 14x squared. I'm seeing minus 18x minus 10. Now, hopefully it's not just me, but this thing looks a whole lot more concise than that thing, does it not? It looks prettier, looks better, looks more concise, more wrapped up. And that's where we want to end our derivatives if we can make it that far. Show of hands, how many people feel okay with what we've done so far? At least up to the calculus being done part. Are you okay with the calculus being done part? After that, it's just algebra, some manipulation. That's okay. What are we doing? We found the what? Slope. That's all we're doing, is find the slope. This is the slope. This is the formula for the slope of that curve at any point that I want. To find the rate of change, or if it's cost, the change. What do you think? Do I have a function within a function, basically? That's what you're asking. Because if you do, then you have a chain rule. Do I have a general power rule here? Oh, explain that. Explain how I have a general power rule, because I don't see an exponent right now. So in order to do this, well, hopefully you remember this from the last couple sections. In order to do the derivative, you really need to represent roots as exponents, right? Because we know we deal with that. We subtract 1 from them. You can't subtract 1 from a square root unless you write it as a 1/2. So first thing to do is go, yeah, all right, I know that this is 5x squared minus 1 in parentheses to the 1/2 power. And that right there says, aha, aha, look, if you can cover it up, you're talking about a composition. Within parentheses, you're talking about a composition. That means chain rule applies. In this case, it's an exponent, so the general power rule applies. Why don't you go ahead and try it? Go for it. You're at that point at this stage.
Alright. And the 1/2 up front. 5x squared minus 1 is now negative 1/2 times 5, I know 10x. It's really 5x times 5x squared minus 1 to the 1/2.
This composition, or the piece of our composition. If we take that derivative, make it 5. How many people got exactly that on their paper? Good for you. Now make it a little prettier. Here's how you can make it a little prettier. The 1/2 and the 10, that simplifies. It simplifies and gives you 5. So we have 5x, and then we have this 5x squared minus 1 to the negative 1/2. How you can write that appropriately would be, since you started as a square root, you probably want to end with some sort of root. We want 5x on the numerator, 5x on the numerator, 5x squared minus 1, and a square root on the denominator. You see why it's on the denominator firstly? Is that negative 1/2 that moves to the denominator? The 1/2 becomes positive, that's a square root. Can I cross out the 5x and the 5x squared? Oh, heck no. No. We can't do that, all right? I see that all day long. Angry. But no, we can't do that. Are you ready to move on from the general power rule? Because that's about all I can show you with that. I mean, it doesn't change after this. If you can do these couple problems, you're okay so far. Are you okay so far? Well, actually, yes, because we just talked about chain rule, but not what you knew before today. The answer would be no. But let's look at it. Do you have a composition going on in this? Which means, can you cover up a piece of it and get some other function, basically? If I cover this part up, if I say cover up the inside, we're always talking about covering up the inside. Cover up the inside, and I say, well, let's let y equals cosine of u, and u equals whatever's under my hand. Would that be an appropriate composition? Because if I let the u go in for u, in fact, x to the 4th go in for u, then I get that back again, right? Well, if we find our dy du,
Alright, what is this called? Pre-calculator. This, of course, the derivative. What is this called? say.
What's dy du here, ladies and gentlemen? We just talked about it. Negative sign what? U. Negative sign u. And du dx. What's du dx? And we knew that dy dx is dy du times du dx. True? True story. This is negative sine u, because that's dy du, that's this, times du dx, which is 4x cubed. dy du, du dx, dy du times du dx, that's chain rule, we just talked about that. That's this right here. What's the one last thing that I need to do? Why do I need to substitute? Don't want to end with u's and x's. We'll make it prettier, but that's the one I want to talk about. This will ultimately become negative 4x cubed sine of x to the fourth. That would be the derivative of that curve. Are you okay with how to do that? Do that 4x cubed out front. Notice what you can't do. Oh, please, goodness, don't do this. Please don't ever multiply those. That's an angle. This is not. This you cannot make 4x to the 7th. If you do that, I'm going to burn your paper. I'm burning. Gone. What homework? I didn't see any homework from you. I'm just burn it. It's an embarrassment. I want you to do that. Just kidding. I wouldn't burn it. But I will go, no, with like 5 exclamation points, and underline it and scribble on it and stomp on it. That's about it. I'm not going to kick a puppy. Not that bad, but are you okay with this? Here's what this says in English. We'll stop here. This says, in order to do the chain rule with this type of thing, you really don't need to show me this. This is just the underlying work. Here's what it says in English. Well, and a little bit of calculus. It says if you want to take the derivative of composition, such as we just had right now. Here's what this said to do. It says, I want you to take the derivative, look what it does, please. It says, take the derivative of cosine, right? What's the derivative of cosine? Negative sine, and leave the inside alone. Does that look familiar? That's exactly what we do with general power rule, right there. Take the derivative of the outside function, the cosine in this case. But then you just can't forget to multiply by the derivative of whatever the inside was. And that's what this says. Take the derivative of the inside and multiply it. That's what we did with general power rule. A lot of people do this. They will give me...
Drink some water real quick. Oh man. Oh, my hair got pressed down, bruh.
They give me this all day long. Oh, it kills me. They say, oh yeah, answer is negative sine of 4x cubed. I get that all day long. See the common mistake that people would make to get that? They go, oh yeah, derivative of cosine, negative sine. Derivative inside, 4x cubed. Is this right? No, because they have not applied the chain rule. Chain rule says you have a composition here. You need to take the derivative of your function, sure, leave the inside alone, then multiply by the derivative inside. So this says you take, I'm going to use a kind of combination of rules here, or notation. You take f prime of x, f prime of g of x, times g prime of x. That's what you do. Derivative of the outside, leave the inside alone, times the derivative of the inside. And that's exactly, do you see that over here? Do you see what that means for us here? Okay, good.
Back it up. Back it up. Back it up. dx. Bro. Jesus Christ. Okay.
Derivative of the function times the derivative of the inside, and that's what we're doing. How many people feel okay with what we talked about so far? I will start here next time with a couple more chain rules, and then we'll keep on moving. Right? So today, we are practicing. All we're practicing today is applications of the three rules that we talked about. Chain rule, which includes the general power rule, the product rule, and the quotient rule. That's pretty much it. What you know from the chain rule is this. This says in English, you take the derivative of the function, leaving the inside alone, and you multiply by the derivative of the inside. If you can remember that for the chain rule, you're good to go. We'll start simply, then I'm going to start building on some nasty looking problems. Because you're home to do example. Okay, sine of 4x to the fifth. A couple questions for you.
Y equals sine times x.
First thing, is this a product rule? Okay, so product rule doesn't apply because this is actually a function. This is really a composition. You know, a lot of people really don't understand trigonometry. They go, oh yeah, it's sine times 4x to the fifth, which is not really what we're doing, right? You can't take, if I just give you sine, that's meaningless. That doesn't mean sine, that means a sin, right? Now, if I give you sine with an angle, that means sine, okay? I'm not going to write sin on your paper. You're not going to write sin. If you write sin without this, you're sinning. In math, that you're sinning, right? You have to have this part. You have to have something with it. If you just have this, that, right? That's not, sine by itself is meaningless. It must have something attached to it. So this is not a product rule. What this is a composition of two functions, a composition of 4x to the fifth into sine. What that means whenever you see a composition is a chain rule will work. If you can cover up a piece of it and you still have a function, that means it's a chain rule. You okay with that? That's chain rule right there. So if we use the chain rule says this. It says in order to find dy dx, You're going to take the derivative of the function, yes, but you're going to at first leave the inside of it alone. So what's the derivative, everybody, of sine?
Cosine.
So we do the cosine, yes. Do we take the derivative of 4x to the fifth right here?
No.
That's going to stay alone. That's this part. Okay, that's the g of x. That says 4x to the fifth. This says you don't even change g of x, and we didn't change g of x. Times, the derivative of g of x. That's where you get the derivative of the inside. You don't mash it all together. You don't take this derivative and the derivative and put it right here. That's not what you do. This should be cosine of 20x to the fourth. That's not it. You take this derivative later, and you multiply it. And I want to see it written out, 4x to the fifth, like that. And then you take the derivative. What's the derivative of 4x to the fifth? That's where we're getting that from. So we're going to have a 20x to the fourth times cosine, don't even need that times, of 4x to the fifth. That right there, that's our derivative. That was a chain rule.
So on the test, you would see ddx.
Yeah, you absolutely want to see that. The way I'm showing you things in class is the way I want to see them on your test. Because I'm going to grade each little part. I'm going to look for this. I'm going to look for this. Right? There's only 2 steps. Don't get lazy and not show me your steps. You okay with that one? Okay, that's a pretty basic one. We're going to start building them up now. I'm going to start incorporating more and more rules so you can start seeing them. You ready for it? Yeah. Let's do this. You know, a really good note to write down here, or at least think about? You want to think about the rules that you're going to have to do before you start your problem. Mostly you think about the most encompassing rule here. So when you look at this problem, what does this actually mean? What does the cosine squared x to the fourth mean? Write it like that. Give yourself a chance at this problem. Instead of just leaving it like this, maybe you write it as cosine x to the fourth squared. Because that's what it really actually means there, doesn't it? We just take a shortcut and put that square there oftentimes. You okay with that so far? Now let's think. Start with our rules. Which rule encompasses the whole problem? Is it a chain rule? Is it a general power rule? I see 2 of them right now. What? I'm going to use a specific, I know they're both chain rules, all right, so they're going to be more specific than that. Which one should we do first? This part, or should we deal with the 2 first?
The 2.
The 2. And what does that 2 say to do? That's the general power rule. Now, it is a chain rule, but it's a specific chain rule. It's like a corollary to the chain rule. It's called the general power rule. So what this says is, I have, if you can cover it up, remember that, it's a chain rule. It's a specific chain rule because it has a power. It's this general power rule. General power. And then inside of that, you're probably going to have a chain rule. Do you see the chain rule as well? If we start with the largest rule, I'll say largest because it's the one that comes as everything. You start with that, then you can follow your ddx. But it's all about how you start. You got to think about that first. You with me?
I need the inverse. See. Ooh, that's bad looks. Let me see. So 2 cosine x. Let me try doing this one. So first thing I do, push 2 to the front. Now we've got cosine x to the 4. And the times the inverse of cosine, which would be negative sine x. X to the 4 I'm assuming. Then you've got to derive the inside. So I think like this. Alright, how would I derive this? Would it be 2? 4 negative sine x to the 3rd times negative sine x to the 4th. Let's see.
Solve for y. Does that make sense for you?
That's the wrong one.
So let's go ahead and do our ddx. What happens to this thing? What are we going to do?
Move there.
So this 2
Drop down.
goes out front. All right. Let's change for my general power rule. So I'm still going to have a power. Is this a what?
Derivative.
Move it with just brutal fun. Yes, tonight. Raise your hand if you're okay with that so far. You see where you see y, you have a cosine there. Do you see why you have a cosine there? This one you do not change. This one you take the derivative of the entire inside function. That's how the general power rule, aka the chain rule, works. Derivative of the function times the derivative of the inside. But now you're done with the calculus up to this point. Now you follow your ddx, and this has broken down your problem, made it a little bit easier. Can you take the derivative of cosine x to the 4th?
Yes.
What rule is that? That's the chain rule. The chain rule says you take the derivative of your function of cosine x to you need to take. You do this. So we're starting to build these rules on top of each other, and you really got to be good at what rule comes first. If you are, then you follow the ddx, and it's just fine. But you got to find that first rule. Once you do that, we said, okay, this probably should be in 4th. Negative sign. Hey, negative sign of what? Is it still x to the 4th or 4x cubed?
X to the 4th.
Good, because chain rule says you do this, but you leave this piece alone for just a second. You leave that alone. In order to find the derivative of this, you multiply by that. So we're starting to build these rules on top of each other, and you really got to be good at what rule comes first. If you are, then you follow the ddx, and it's just fine. But you got to find that first rule. Once you do that, we said, okay, this probably should be written like this. This says general power rule. You bring it down, you leave it alone, you multiply by the derivative of the inside. Then you follow the ddx, and it's just fine. But you got to find that first rule. Once you do that, we said, okay, this probably should be written like this. This says general power rule. You bring it down, you leave it alone, you multiply by the derivative of the inside. That's where we're getting that from. You okay with that? After that, calculus done. Just keep on writing. Keep on writing. This ddx says take the derivative of this thing. Now this is a chain rule. Chain rule says I take the derivative of cosine. Got it? But I leave the inside alone. Just like you left the inside alone here. I leave the inside alone. And then I multiply by the derivative of the inside. That's where that's coming from. Rich, you feel all right with that so far? Good, all right. We're almost done. We only have one little teeny derivative to take. What is it? Yeah, you know what? Every time you do a step, it makes it easier. Sometimes. But every time you use a rule, it breaks it down into little pieces. Negative, 2 cosine x to the 4th times negative sine x to the 4th times 4x cubed. Just make it maybe a little prettier up here. A little prettier would mean you have a negative, you've got a 4x cubed, and you have a 2. They're all being multiplied together. You see the multiplication? Take that stuff together. So this will be 8 negative. Negative 8 x to the third, then the cosine or the sine, and then the sine. And that's how I'd like to see your problem. After this, it's just algebra. It's just putting a couple things together. You have 2 times negative 1 times 4, that's your coefficient, that's negative 8. The x to the third, we typically like to bring that up front. Can you follow that? Yes, no? If yes, great. If not, do you have a question about it? Guys? Anyway, no, this is technically right? This is it. So no matter how you, because multiplication is commutative, associative, doesn't matter how you group them, how you put in order, we typically just write numbers and single variables first. Move on. Hey. Okay. This is actually kind of a more friendly problem. A little bit. Do you see why it's a more friendly of a problem? If I had done this, would it be a friendly problem? No, it would be your enemy. If I did that, what would you do first? A chain rule? They're both chain rules, but a chain rule or a general power rule?
General power.
That would be just very similar to that problem. You would have to bring down the 4, all of this to the third power derivative of the entire inside thing. Do you see it? Without the power, what are we talking about here? That's the chain rule. Just see if you can cover something up and you still have a function, that's typically a chain rule. So we still have a chain rule right here. It's not a product rule. That's not a product. It's tangent of something. That's a chain rule. It's composition. Well, let's do it. How's a chain rule work? What should we do first, please? Wait, do what now?
Outside.
Okay, cool. So leave this alone. Take the derivative of that thing. So this says I'm going to have, tan. What's tan? Very good. Make some flashcards. Know those derivatives. Secant squared. Does the inside change for us right now? Okay. Done? No.
Multiply the inside of the inside.
Can you tell me what the inside is here? Is it tan of this or just this? Just that part. This is just a chain rule. It says derivative of tan, the secant squared, leave the inside alone, then multiply by the derivative of the inside. That's what the chain rule says to do in English. Got it. Secant squared, cool. Inside doesn't change, derivative of the inside. That's the chain rule at work. Not too bad. What are we going to do? Just follow the DDX. This is basically done. You're going to get a secant squared. But what people often forget to do is this piece of it. They really often forget to do the chain rule. They'll do this for me, but they'll forget this part. I can't have you forget that part. That's a big part. That's a really big part. Or they will do secant squared, and then they'll take the derivative and just mash it together. So if you're giving me this, well, that's not even nearly right. You changed the angle. You've messed that problem up. All right. That's not what we're talking about. You can't just take derivative of this and derivative of that. This is definitely a chain rule because it is a composition. See the difference there? Okay. So for us, we go, no. Not that. This is...
No. Why can't you?
Why can't you?
It's a angle.
What is that?
It's an angle.
That's an angle. It's actually an angle that's related to this.
No, not this.
I mean this.
I thought you meant
No,
distribute
these
the
two.
whole thing. Okay.
Can you distribute these two?
No.
Negatory. No. That's not an angle. This is attached to that secant squared, okay? That's part of it. You can't change the angle. What we can do is move this to the front so we don't distribute it. You probably wouldn't want to take this thing in and you take the whole thing. You wouldn't want to do that. Okay, it's already factored for you nicely. Don't do that. Just leave it as 6x minus 2 secant squared 3x squared minus 2x. Tell me one huge thing I'm going to mark you off on. For sure. Yeah, for sure. know what? No, I'm not gonna be nice. There.
Great way to say things.
Okay. I was just gonna give you an X, but I want you to see what happens. So this will be a little bit more difficult. Trust me, you want the more difficult ones now. That way your homework seems easier. If I just give you all the easy ones now, your homework should seem like a bear. So you want to do that.
Okay. Let's see. X cubed plus CFCX3. What time? The 1/2. So power rule at first. Power rule says put the 1/2 in front, and then everything in here plus minus 1/2. I gotta multiply by the inside. 3x squared plus, it's the inverse of cosecant. Is net what? So it's a minus CSC of x to the third times cotangent x to the third. Jesus.
Okay, I'm lost. What do I do?
General power.
Why would you say general power rule? Okay. So chain rule, general power rule, same thing, but we're going to say general power rule when we have the exponent, so we can classify this a little bit better in our heads. Okay. So all that inertia, right? So far, so good. Notice how we're not changing that. The inside does not change for our chain rule, which also includes a general power rule. Do I still have an exponent? Or do I just get rid of that exponent? Do I still have an exponent here?
Yes.
Don't forget about that exponent, man. Oh my gosh. If you just move down the 1/2 and forget that, that's a big deal because you've eliminated the square root on the denominator there. So this really needs that negative 1/2. Do you see where the negative 1/2 is coming from?
Yes.
Okay, nudge it if you do. You feel okay with it? Now what do I do?
Hold on. This would go in front. It's probably gonna go on the bottom regardless. I think that is it. Oh my gosh, I might. Please tell me I'm right. Please tell me I'm right. Please tell me I'm right.
X. Yeah, I know that. But
Fuck!
do you see where it's all coming from? How it's all fitting together? Is it really all that bad? Not really. It's just you got to be careful. really careful. I mean, probably the hardest thing is memorizing cosecant. And you go, hardest thing here is derivative of cosecant is negative cosecant cotangent. Hopefully that's right. Is that right? Just check your notes. Okay, all right. Because here, well, general power rule, sure, we got that down. Calculus is done. Here, derivative of this one, very easy, 3x squared. Derivative of this one, that's chain rule. This is inside. This negative 3x squared. Hope that fit. I think so. Sure.
Now the 3x squared, is that going to get multiplied with both of those terms?
Why do you add it?
The x cubed plus.
You mean here and here?
Right. Or does it just stay with cosecant cotangent?
This right here ends the parentheses right there. So that 3x squared, this 3x squared is not associated with that x cubed. Right? So this does not get distributed to here. This right here is 3x squared plus this entire nasty looking expression. Okay, that's what that is. So when we try to simplify this just a little bit, let's look what happens. Or like, 3x, we're going to get a big bracket. 3x squared doesn't change, you don't distribute to that. That was just a standalone small derivative 3x squared. This, we're going to pretty this up a little bit. Positive, negative, plus, minus, what's that going to be? Minus. I'm going to move the 3x squared out front. So this will be minus 3x squared cosecant x cubed cotangent x cubed. And that's your derivative.
Holy moly, bro. What? That was so genius too, bro. Fuck. Clean this up. Right now, you should check your phone, perchance. Did you blow up my phone? Oh, wait, what is this? Hold up. Would any of y'all be free this? Alright, I got you. You should check your. Oh, yeah, I thought you were about to blow me up with Life 360 or something. Alright, yeah, I see what you said. I've got your answer, Cooper. I've got your answer. Hold on, let me find it. Alright. What the hell? Why? It's gotta be. Is Emmanuel in here too, bro? 4 people. You got 15 minutes.
That's pretty nasty. Can you follow it? Yes or no?
Hold up. Three. x squared plus minus cosecant times x3 cotangent. Jesus Christ, x3. What in the fuck? Oh my god. Oh, hold up. I got you, bro. I got you. Oh, wrong one. Here we go. Hold up. Can I? Where's my freaking? Alright, whatever. We'll do this. You have the audio off? Alright. Do this. No. What? I have an idea. Helping y'all goon. Let's try this. Oh wait, fuck. No one understands the mask I have on. Oh, oops. Oh, fuck. Everyone is a tool to me. Everyone is a tool to me. Oh, I'm back. There's y'all gotta be bored as hell, bro. I swear that's not even that funny, bro. Alright, let me take this off. The photo you were putting up didn't show up on screen. Only Emmanuel can hear you. So you just look schizo act. The photo you're putting up. What photo? Wait, how? Oh, it didn't. Oh shoot. Fuck. All right. Oh shoot. Is there any way I can? Oh my days. Is there no way I can freaking? Yo, what? What is this? Son, where's the freaking? Where's the image I had? Oh man, I don't know how I can. Oh, I have an idea. Mr. Krabs, I have an idea. Oh, wait a minute. If I do this, and I go here. Alright. Oh, that's Wordle. How close am I to the photo? I've got to wait for my stream to buffer. The chat blocks it, bro. Alright, we gotta turn off the chat. Come on. Fuck. Alright, move a little closer. That. Fuck, I'm too low. Get close to it now. Everyone is a tool to me. Alright, I actually killed myself. I'm never run the back turbo. Oh, fuck. Goes back to full. Alright, here we go. Oops. Alright. Wait, fuck. Return the fuck. Check. Here we go. Alright. Yeah. Alright, lock this one in. Alright. Enough goons. Oh, man. Oh, man. Everyone is a tool to me. Can I just like... I probably can. Let me see. Oh, go to my thing. How do I... 31 followers. Shit. Who actually... I don't even know how to clip. Yeah. Am I the best streamer, bro? Fuck. What if I just go to my home anyways? Damn, bro. I guess we're not doing math anymore. Fuck. I actually gotta finish this problem, though. Goober save the Soul Society. Wait, how do I fucking... Oh, but this... I should be the one who knows how to clip my own shit, bro. Fuck. Oh, here we go. Go here. Can I just clip anything, though? Oh, my PC's crashing! My PC's crashing! Knock. Why the hell do I have 34 views on my freaking other? What the hell? Wait, can I just... Wait, what am I doing? I have a whole freaking browser to... Can you clip Twitch? VODs? All right. Fuck. I got 4 minutes. Let's tap in on the final 4 minutes.
This is
Wrong video.
yeah. Or like
There's no simpler way. To, can you?
What the heck is this photo? At the lake house. Oh my god.
You correct. If you go 3x squared minus 3x squared cosecant x cubed cotangent x cubed over 2
Sure.
times.
I'm gonna show you that right now.
Yo, I'm so
If you
fucked,
do
bro. I don't
back
understand this,
to
bro.
This format.
Or I
this
do,
would
but it's
be-
just
I mean,
a
like,
lot.
do you want us to, or can we just leave it as that? Because I mean,
At this point, it could go either way. If I give it to you as a root, probably think it back as a root. That's generally the idea. Give it to you as exponents, leave them to exponents. Also, one more thing, if some of you guys want to get fancy with this and factor out 3x squared, you'd have 3x squared times parentheses 1 minus that. Sometimes identities will help with that. Sometimes you can do identities, a lot of 1 minus stuff when you have squares happens. This thing, I don't know if you can simplify that anymore or not. Because I made stuff off my head. But what you could do, one last final thing would be this. If you made it there, if you can make it there, that's fine for me.
Yeah, that's what I was thinking.
That's great.
What the hell? Jesus.
So we did general power rule, we got it. Here's inside not. All right, you asked for it. We have 3 more actually.
3?
the hardness for last 2 and for 1.
Yeah.
15 minutes?
I am Maroon.
That's not a good sign.
Alright, well. What days? That's enough calc today. I'm tough. We'll be on the BRB. I'm gonna go grab. All right. Yo. Cooper.
Yo.
All right. Hey, check this out. Check this out. Is this gonna be
You can pull up, right?
Yeah, I'm down to. I just gotta ask my parents because I don't know if they're gonna end up letting me go or not.
All right. Yeah. Probably leave early Saturday morning. It's like a 3.5 hour drive.
All right. Chapter 5. Ooh, ooh, ooh. Oh yeah, no. Who's in the? Ooh, Fucking god. It's too loud. I want to finish eating. Let's see. Watch speed, bruh. Yeah, my God.
5-0.
What?
5-0.
The match just started.
Score prediction. 4-0. Do you like Ronaldo? Yes. How long? 10 years. Why do you like Ronaldo? Because he's the best. Are you a bigger Ronaldo fan than me? Probably not. He's not.
Damn, bro.
Hey. Score prediction. Portugal. 100. 6-0. Score prediction. 1-0. 1-0. No, 3-0. Hat-trick. Hat-trick for who? Hat-trick Ronaldo. Why is the Messi fan at a Ronaldo game? Hat-trick. Why is the Messi fan at a Ronaldo game? Yo, respect. Why are you here at a Ronaldo game? Why? I had to see one of the best players in the world. I respect it. Why are you wearing a Messi shirt? I don't have a Portugal jersey. Why? I don't know why. It's just there. When I got the Messi Ronaldo, son. Ronaldo's better. Goofy ass dude. Goofy dude. All right, your hydration break is over. I peed. I feel great. Come on, man. We need a goal, bro. Thought I better score? Oh my God, this is the first time I'm in a live? Chat, if this is your first time in a live, then say this is my first time. Because we need y'all luck, all right? We need, like, if this is your first time in a live, I hope you really get to see Ronaldo score with me. But this is gonna be, oh my God, here we go, this is it. Cross to Ronaldo. Dang it.
What we got? Maybe we don't do this. I'm just only at 500, almost at 500,000, bro.
This is my 2007 Nissan 350Z, and right now I'm on the journey to make this car my dream car. Just as a quick recap, we bought this car from Wyoming and drove it across the country. We then cleaned it up, threw on a new exhaust, which sounds insane by the way, new spoiler, and finally wrapped this car to this beautiful green color. As of now, this car is really starting to become my dream car, but it's not there just yet. We still have so much more to do to this, and I just got a lot more parts in the mail. And today is a great day because oh yeah. There's the front. I just got these BC Racing coilovers in the mail. So far, just from unboxing it, I'm impressed with the quality, but you know, you can't judge a coilover by its cover. You gotta judge it by how it rides. My biggest fear is this being super bouncy and stiff. I don't wanna be one of those static guys just bouncing around. So let's put them on, starting with the fronts. First, let's get this car on the lift. Before we take any wheels off, the first step in this process is to unbolt this front strut bar. The top of the stock suspension is covered by this bar, and as you can see now, we can access these bolts holding it in. We then unscrewed all but one of the bolts just in case it drops down, and now with that done, we can lift the car up again and take off the wheel, which I then figured out there was a spacer on the front. Anything larger than 1/4 of an inch is technically illegal in my state, but like, Now let's get this old suspension out, and the process was super easy. We just had to move the brake lines, unbolt a few bolts holding in some wires that I honestly have no idea what they do. Then we unscrewed the bottom of the suspension, which was stuck, which makes sense. It probably hasn't been taken out ever. But to get the bolt out, we needed a pry bar.
Yeah, I think we need the pry bar.
What, this one?
No, no, no.
So we used the not comically large one, and the bolt came right out. The suspension wouldn't come out, so we just kept unbolting a bunch of stuff until eventually we had enough room to sneak it out of the car. Hello? So out with the old and in with the new. Before we put it in though, we set the bump stop, which basically just prevents your wheel from smashing into your fender when you hit a bump. And to do this, we put the new suspension in with no spring and the wheel back on. And as you can see here, the wheel goes straight into the fender, which is not good.
That's no bueno there.
So we took it off and adjusted it so it won't do that anymore. And now we can reassemble the coilover and bolt it in for good this time. We then reattached the lower control arm, then the coilover to that control arm, and just put everything back how it was. Lastly, we put the wheel back on, and now for the moment of truth, let's lower and see the huge difference. There's literally no difference. But I did it like this on purpose because once I get every single side on, I'm gonna slam and camber the car as far as I possibly can at once. So for now, it's just gonna continue being super high off the ground. We then did the exact same for the other side, taking the old one out, setting the bump stop, and bolting everything in for the new coilover. Easy as that. I really wanted to film a slow-mo montage for this, but I forgot, so enjoy the only clip I got. I still think it's pretty sick if you ask me. Lastly, we put the strut bar back on and bolted it back into place. And with that, the front coilovers are officially on. Now let's move to the rears. This process was a lot easier than the fronts and also allows us to get rid of this giant heavy spring since it's being replaced by a coilover. But now with that off, we can take out the old shop. Look how much stuff is being replaced. That is some weight reduction right there, which equals more power. We then put in the new coil, and now let's replace these old camber arms to the new adjustable ones I just bought. So we took this bolt off from the rear camber arm, which in the process rudely interrupted my reading session, and replaced it for the new one, meaning this side is done. We then went ahead and did the exact same thing for the other side, and just like that, all of the coilovers are on this car. But before we slam and camber this car completely... Okay, quick break from the video. Yes, I'm filming this before we slam this car on the ground. This thing is still a monster truck. But if you guys drive a car, buy groceries, or go out to eat, so literally everyone in existence, there's an app where you can get fast, easy cash back on these purchases called the Upside app, the sponsor of today's video. Let me show you how this works. Okay, so as you can see, my car is pretty low on gas. First, you open the Upside app, then claim your offer, pay with your card like normal, and then you get paid. That's it. It really is that simple, and it adds up a lot over time. Especially with today's day and age with gas prices that look like this, it's like a no-brainer to use it. And with Upside, it's not just in-app points used towards useless stuff. It's money that you can transfer straight into your bank account. Right now, there's over 100,000 participating locations, meaning there's probably some locations you already fill up with that you could save money just by using the Upside app. I use this, and you should too. I personally love saving money, so checking the Upside app before I fill up is just a part of my routine now. Upside has given back $1 billion to its users. To find out how much you can earn, download the free Upside app and use promo code DougVargo to get an extra 25 cents back for every gallon on your first tank of gas. That's an extra 25 cents back for every gallon on your first tank of gas using promo code DougVargo. Huge thank you to Upside for sponsoring today's video. And now, without further ado, let's lower this car as far as we possibly can. Okay, so we got the coilovers on the car. It definitely is a lot lower than it was before. Obviously, we still have to set the correct ride height for it, but just for fun, I want to lower it all the way and camber the rear wheels, just absolutely slam it on the ground. Why not? I mean, free will, but now that's not good. We need to fix this right now.
Boa Hancock. I'll be right back real quick. Let me see this. All right. Tap it. Chapter 4. All right. Let's go. Let's do some math real quick. 115 for 250. Get my iPad out. Alright, I got my calculator. Divided by 115. So you're getting 2 heals per dollar. 2.2 roughly 2.2 heals per dollar. 450 divided by 160. Okay, I'm doing a fucking math wrong. So, but you can just get 2 of these for one. Ooh, I might need one of those. I'm not gonna hold you, bro. Got buffs. This is stuff that buffs Susan's stuff. Peacekeeper scarf. I need 2 of these, bro. Unversive. Let me go my inventory. We gotta revamp our stuff. That's it. Hold on. I know you sell the glow shards, right? I thought you sold them. dash is pie. Water gun? I just freaking screwed myself over. Actually, it's not that bad. To see the wait for that. Alright, I don't even know what I did, but that's myself. It's good to me. What? Extreme Go Choir 3, 2. Duh. Oh, sad. What the heck? Whoa! What? Oh my days. Whoa. Who was this tool? His chariot cannot be stopped. The king's chariot cannot be stopped. What? Oh, what? Let me get to the details. Absorb X. That's it, bro. What the hell? I gotta remember. Like. Wait, what the hell? Oh, motherfucker. box have some ulterior meaning or some shit, man? Oh, it's already here for me. Alright. What the hell is Konami? Wait, this guy Toby Fox freaking based this shit off of whatever Konami code is. What is this? The most famous cheat code in gaming history. Don't say anything. Why? El Rousey, bro. There's some tension, bro. I'm back here. Just gotta make sure. What? Who dare bring light here? We're going left to right, left to right, left to right. Right? Oh, so that just you shit. Go back. You sudden come here. Sudden come here. This zone is forbidden. Continue. And you may find yourself spooked in the dark. Oh, it's only getting darker, guys. Yo. Very well. If you come close to this place, then you may find the dark. Oh, that boy big as hell. Darkness constricts you. TP game reduced outside of treasure. Jackenstein. I'm like. Whoa, there's no Skype in the dark. Oh, hell no! Just freaking touch it. Because I'm pumped about it, so just keep that. Yeah, I can't do shit. Fuck. Oh my. What? Oh my, I'm actually just getting touched. Ah! Yeah, I need to heal. Gotta stop doing these teeth, bro. Are we dead ass? How do I get out of it? Oh, it's me after you. Come here, boy. Come here, boy. That's how long? He's not even in here, just kill me. All my days I'm gonna grab a ton more freaking teas after this, bro.
Mommy. Mommy. Mom.
35 is the max it could go? What? Fucking what? Son. Oh man, I might be able to get there. Yeah, that's how I die, bro. Son. I'm slow. Alright, bro. What's up, Jason? God damn! Back here, you ball. Motherfuck. Oh. Come here, boy. Come here, boy. Come here, boy. Come here, boy. Vamos surfar de chás, que é o que eu sei. Okay, this is the freaking ah. Health for not healing, bro. Crap. Mamma mia! Yo! I'm about to say. What the heck? Why he look like that? Oh, I probably should have said that. This guy goes got old, bro. Yo, why is it actually like this is deep, bro? Gerson ain't gonna be there, bro. Yo. So much more. Wait, where'd I come out of? What the hell? Uh-oh. Motherfucker, I don't remember this. Oh, my fucking tune is getting so bored, bro. Oh, it's over! It's over! Yo, I'm just taking damage? What the hell? Yo, Gerson's the freaking goat, bro. What the hell? Where's everything beautiful? You must locate 3 hidden song fragments in art and defeat the hammer of. Oh shit. Oh, I know who the hammer of justice is. Oh shit. What the? Yeah. Goddamn. To do it for her. Oh. budget 10. I'll put a 10 for it. What? shit.
Here's how to find the secret boss in Deltarune Chapter 4. At a point in the chapter, you'll reach a place called the Study in the Dark World. Once you unlock the ability to climb up certain walls, return to the study and go upstairs. There, you'll find the golden piano. Now, the notes combination that you have to play on this golden piano are hidden around the local area. One is behind the waterfall in the wishing room, and the other two are in rooms before the study that you have to climb up to access. Once you gather all notes in each room, congratulations, you have unlocked the secret boss. Have fun. Here's how to find the secret boss in Deltarune Chapter 4. At a point in the chapter, you'll reach a combination that you have to play on this golden piano are hidden around the local area. One is behind the waterfall in the wishing room, and the other two are in rooms before the study that you have to climb up to access. Once you get
Up there, up north. What? Damn, why is this thing actually thinking? What the hell?
What happens if we don't let the old man recruit anyone in Deltarune Chapter 4? Spoilers ahead, so watch at your own Mr. Generosity. After the prophecy gets smashed and Gerson jump scares Susie, you'll end up in fights where you can use Gerson in your acts. During the Balthazar fight, whether you ultimately spare one or both, Gerson's act will still tell him to go easy on you and feed everyone but Susie candy. But what about during the Gue fight? Here, when you use the Gerson act where Gerson drops his cane, if you actually get hit during this part, Susie will blame the cane for you all getting hit, even though his cane is actually the safest place. Also, whether you leave both or only one alive before Gerson's second act, he'll still ultimately spare them with his dialogue staying the same. Though instead of having both Gue in his study, you'll only see one depending on which one you spared. But what about if you defeat both Gue by fighting? Well, Gerson will wonder if you had to be so rough on the Gue, but Susie will say it's a battle, so what does he expect? While Ralsei calls you out on sparing not being important to you. Not only that, but when you go to the study and ask Gerson why he needs money, instead of him saying it's to feed his recruits, he'll say it's to save up for his retirement, as even Susie admits the economy is tough. Follow for more secrets, like what happens if we don't let the old man recruit anyone in Deltarune Chapter 4? Spoilers ahead, so watch at your own Mr.
Okay.
Of Deltarune. After defeating Jackenstein to acquire the climbing tools, go north of the Old Man Studio to find the Golden Piano. Its melody required 3 parts. The first one can be found behind the waterfall. How to find the 2 secret bosses in the first one can be found in a woodsman was found for a wall in the screen with the spirits and the lantern. Find the first of the secret boss in the lanterns. There, you will also find the first of the secret bosses, Miss Missile. With the 3 melody parts, play the golden piano to open the door behind the old man. There, you'll find the magic axe and the fight against the Hammer of Justice, the final secret boss. But do you know how to fight?
Shit. pay for that. Price tag. A battle. Oh, I was gonna say in a battle or some shit, bro. Whew. Ooh, he speed blitzed her. It's only first. Can you hear it? Can you hear its song singing from the deep? That is the ringing. Ooh. The hammer of justice. Oh, fuck. Oh, this is like under? I gotta tap in, bro. Alright, got this. But this is us. Yo! God damn! Nah! The great smith gives the heroes a terrible weapon. Yo. Give your best shot. How am I gonna do this shit? Fuck. The field of pink and gold? I thought that was like... There's only one more chapter after that, and I'll stop. It's only 6 fuck! Is there only gonna be 6 or 7 chapters? Oh, fuck. Fuck! Holy shit. Oh my god, I'm not even a minute into the freaking fight, bro. Fuck, I already fucked up. Yeah, I'm just eating. Oh my days. Oh, I didn't even get it right. What the fuck? He's just going in all my directions. How? Oh shit, bro. Birdley's probably gonna play a big role in chapter 5, I think. What? Oh my god. Oh my gosh! Brother. It's literally just fucking targeting me. What the hell? Oh my gosh. that hurt. Oh, I fucked up something on my forehead. Ow. Oh my fucking god, bro. Jesus Christ. Oh my days. Tired, bro. Motherfucker! Fuck! bro. Woo! Fuck! I can't. I gotta clutch up. I gotta clutch up. Fuck! I gotta clutch up. What am I running into? What the hell is what I have to do? Oh my, I'm whiffing. Oh my god. close. Fuck. In, bro. Let me tap in. Please! Please, speed! Fuck! Oh, I'm so omega pumped. Oh, I'm so cooked. No! 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 Oh my god. Fucking bastard. Fuck! God damn. W person, bro. What? Alright. This is it, bro. Fucking roaring night. Night which makes with the blackened knife. Shall do with yours strife by strife. Oh shit, we're back. Alright. The fuck? Oh shit, the music just stopped playing, bro. Yo. What's up with this fucking war on this shit, What the fuck? Yo, okay. Oh. not gonna work. There's like oh, yeah, switch, W character development, bruh. What the? Oh. Letter A. Oh. sharp. He has a dagger or some shit, What the heck? What is going on? I don't know. What is going on? What love? Blade. That reminds me of freaking Jello, bro. Damn, Wingblade. Well, no Wingblade recruiting. I already recruited you! Once it's freed, the roaring cries and tight shivering darken the eyes. The third heard the prince alone in deepest dark. Yes, all things Who is this? I'm the philosopher. Oh. Crap. Organic. Damn. Wait. So we're in the future now? Wait, I don't think we're gonna find Gerson then. The voice reads, moved by red word. Talk about Tenna. Maybe something's Whose dream is this? Person's dream? First year the gauge of Cuban solar pulse. when you pass to the other side of relation show what the hell? Second what the hell? Girl. Look at that. Doesn't tell me what the hell. Okay, I'll watch it. Oh. Damn. Damn. God damn. Oh, my first match. Oh, I ran right into it. What the hell? Oh, I ran right into it. Gallery. I want the pleasure. See if that goes in one way. It's a Gerson. Oh shit. Oh. What the hell? Careful. So sick. Soul Man's yeah, here, bro. chills, but I don't like the feel of this. That's not him, is it, bro? That's someone else. Ooh. I don't like this, guys. As soon as you don't know how to read freaking context clues, right? Alright, bro. Bro, leave me alone, son. Oh, that can't be good. I don't like this, bro. What the fuck? The complete darkness seems there's nothing left to do but close your eyes and think about how Susie's doing now. Yo, our trading paid off, bro. much longer is in chapter 4? What the fuck? That's calm, bro. That shit calm. That's calm, bro. Something you gotta recognize. She could bring up the X. Oh, brother. Ooh. Oh shit. What the hell did Rousey do? What are the statues in the shape from this? This is about to spitball, bro. That's why freaking Rossi didn't do her room, bro. It's because Bo knows she's gonna die. Five is a code, bro. Yes. 2202. Yes. All right. Damn. Let's go. All right, bro. Let's go. Oh, it's doing it again. Prison only you can see. Damn, bro. Oh my goodness gracious. Oh my days. Oh. How much did oh good. God damn. Shit. Damn, mouse is down. Yeah, I don't think I need to attend the meeting. I don't know what that is. Swoops you back to start that sanctuary. Alright, I have no idea what they're talking about. So I'm about to find out. God damn. That's no. Legendary? Damn. Stick together. Yeah. Jesus. God damn. Fucking hell. Okay. They got me on 1 HP, bro. We did ass. Maybe I'm doing something wrong, but like. What routes we were on? Bro, that's another fucking spawning, bro. Oh shit. There's a marble? It's over. It's over. Don't. Oh shit. Don't make another fountain. Damn. I don't think we could yeah, I don't think we do anything wrong. We might need a time skip, bro. I think we gotta get a top skip like Luffy. Bro. Oh, hell no. Oh, this is not Attack on Titan, bro. What the fuck? It's a Titan. There's no time to explain. Everyone climb on. Everyone attack is there's so much, bro. What is going on? Okay, No! What did I land on? I'm at 1? There's no way I'm at 1. Yo, bro, max this shit out. The light and dark were burning dire countdown to the ocean's bar. I thought we wrote this. So that's the title. Shit. Gerson! That's about a jump or something. Oh! Oh! Yo, I don't like it. Oh my days. Shine bright like a diamond. Shine bright like a diamond. Is coming. Yo, that dude killed about it was crazy. I didn't know that shit powerful. Oh my days. many of them. Oh my, it's 21 minutes? Jesus. Oh my god, bro. Fucked. God, bro, how much longer? Holy shit. fucking shit. Yeah, bro. How do we have 2 people down, bro? Oh my fucking god. Oh my fuck. Alright, I just fucking split myself. God damn it. Oh, oh my god. Fuck is down, bro. Fuck you. Oh, hell no. Oh, hell no. Damn. Bro, what did you do? Yo, ain't that the Undertale freaking? Oh my days. Right. Should tighten if we do that then. Where's Susie? Oh. The last prophecy story's end. Damn. And then when all hope is lost for the tale, the final tragedy unveils. Oh shit, what's gonna happen to save the world or something where bro's gonna die or something. Alright, bruh, I guess. Change. Damn, they're really freaking bringing out the piano, bro. Only then will the world be saved. No matter what, I want to keep being friends with you, and I'll see you. The sun comes out. Just as soon as I didn't know where things were as if in imitation That's it, chapter 4. Oh, wow. We gotta explore the place, bro. This place got ransacked. Bruh. That's it. Oh my days, the other half of the song. Oh my gosh, these like the other key characters we're gonna. Which is red. Yo, I'm actually getting shivers right now, bro. Damn. It's tough, bro. The place where we're in. Damn, locked. It's closed. Bro just wants to go. Damn, it is dead back here. Let's go to your house, bro. Just wants to go home. Damn, come back here. skippable cutscene we had to play, bro. Jesus. Let me out. Let me He's about to get taken out on me, bro. Oh. What's Susie doing? Oh. Oh. Forget what? Alright, bro. You son of a bitch. You son of a bitch. Well done. The halfway mark has been attained. Holy. But it is still waiting. How much longer now? Well, chapter 5's wrap coming out in a week, bro, so we chilling. My Deltarune. To be continued in chapter 5, 2026. Alright, bro. I'm fucking finished.